Disadvantage of steel as a structural material. Corrosion. Most steels are susceptible to corrosion when freely exposed to air, water, and therefore must be painted periodically. The use of weathering steels, however, in suitable application tends to eliminate this cost. Though weathering steels can be quite effective in certain situations for limiting corrosion, there are many cases where their use is not feasible. In some of these situations, corrosion may be a real problem. For instance, corrosion fatigue failures can occur where steel members are subjected to cyclic stresses and corrosive environments. The fatigue strength of a steel members can be appreciably reduced when the members are used in aggressive chemical environments and subject to cyclic loads. The reader should note that steels are available in which copper is used as an anti-corrosion component. The copper is usually absorbed during the steel making process. So from this one, what we can understand is that corrosion is a main disadvantage when we use steel as a structural material, and to reduce corrosion, the anti-corrosion component, that copper, is sometimes added. So copper is usually absorbed during steel making process. Okay, the fatigue strength, it will be appreciably reduced when members are used in aggressive chemical environment subject to cycle loads, like when we are using the member in the salt water locations and where it's subjected to waves and cyclic loads. The fatigue strength, it will be reduced a lot. Corrosion fatigue failures can occur where steel members are subjected to cyclic stresses and corrosive environments. So weathering steel can be quite effective in certain situations for limiting corrosion, but however their uses are not feasible. In some situations, corrosion may be a real problem. So it's very clear, like whenever we expose the steel to air and water, they are susceptible to corrosion, so that must be painted periodically. Another disadvantage of steel as section is the fireproofing cost. Although structural materials are incombustible, the strength is tremendously reduced at temperatures commonly reached in fires when the other materials are in a building burn. Right? Many disasters of fire have occurred in empty building where only fuel for fire was the building themselves. Furthermore, a steel is an excellent heat conductor. Non-fireproof steel members may transmit enough heat from a burning section or a compartment of building to ignite materials with which they are in contact in the adjoining sections of the building. As a result, the steel frame of a building may have to be protected by materials with a certain insulating characteristics, and the building may have to include a sprinkler system if it is to meet the building code requirements of locality in question. So another problem with the steel is fireproofing cost, because even though steel is incombustible, the strength is getting reduced tremendously at temperatures commonly reached in fires when other materials in the building burn. So if some materials in the building burns, then it will reach some fire will happen. That because of that fire, the strength of the member is tremendously reduced. So this is another disadvantage. So steel is an excellent heat conductor, right? So if we are not fireproof those steel members, it may transmit sufficient heat to from a burning section to other compartment of the building, right, to ignite materials. If some materials are ignite, yes, flammable material are in contact with the adjoining sections of the building, they will also get burned. Another disadvantage is susceptibility to buckling. As the length and slenderness of compressed member is increased, its danger of buckling increases. For most structures, the use of steel column is very economical because of their high strength to weight ratios. Occasionally, however, some additional steel is needed to stiffen them so they will not buckle. This tends to reduce their economy. So whenever we have a very high cylinder member compression, its buckling stress is danger of buckling increases and buckling stress reduces. So most of the structures column we are using is for economical purpose because of their high strength to weight ratio. However, we need to stiffen them because so that they will not buckle. So because of this additional stiffening, there may be some reduction in the economy. Next one is fatigue. Another undesirable property of steel is that its strength may be reduced if it is subject to cyclic, a large number of stresses, reversals, or even to a large number of variations of tensile stress. Fatigue problems occur only when tension is involved. That also, the present practice is to reduce the estimation of strength of such members if it is anticipated that they will have more than a prescribed number of cycles of stress variation. If the steel is subjected to a large number of stress reversals, its strength is getting reduced. Even if the stress variations of tensile stress only, large number of variations in tensile stress. For example, now the tensile stress is 20, next loading cycle tensile stress is 10, next loading cycle 30, next loading cycle 20. Like that, if it's getting a large number of variation, even in tensile stress, fatigue problems can occur only when in tension is involved also. Okay. The next disorder is brittle fracture. Under certain conditions, steel may lose its ductility and become brittle. Fracture may occur at places of stress concentration. Fatigue type loadings and very low temperatures aggravate the situation. Triaxial stress conditions can also lead to brittle fracture. Under certain conditions, steel may lose its ductility. If it loses ductility, it becomes brittle. So brittle fracture may occur at places of stress concentration. Wherever we have too much stress concentration, that locations there is a possibility of brittle fracture. Fatigue type of loadings and very low temperatures aggravate the situation. If the steel is used at the service very low temperatures, and it will aggravate the situation of brittle fracture. Triaxial stress conditions can also lead to brittle fracture.